Good evening, guys. So today I'm going to discuss about the question number 5.13 of work energy power from NCERT. Okay. So let us read the question. At first, before doing anything, you should read the question. A raindrop of a radius 2 mm falls from a height of 500 meter above the ground, and if it falls with the decreasing acceleration due to viscous resistance of air until at the half of its original height, and it attains its maximum terminal speed and moves with the uniform speed thereafter. What is the work done by the gravitational force on the drop in the first and second half of its journey, and what is the work done by the resistive force in the entire journey? Okay, so we need to understand what they actually tells. Okay, so let us consider there is a raindrop, right? There is a raindrop and it is falling, and this is your ground. This is your ground, right? So when rain will drop, so what is the total height of this raindrop is 500 meter, and there is two part. At this part, what they are telling, at this part, they the it attains drop attains terminal velocity. What do you mean by terminal velocity? Velocity, it means that its velocity will remain constant after that due to air friction. Okay, we need to find first question, we need to find that what is the what is the work done by the gravitational force on the drop in first and second half. So it is your 250 meter, and second half is also your 250 meter. Okay, so we need to find the work done, okay, by the gravitational force. So before doing this, so what is the mass of the what is the mass of what is the mass of the raindrop? We need to understand what is the mass of the raindrop, right? So can you find mass of the raindrop? See here, radius of a raindrop is 2 mm. Can we write here 2 into 10 power minus 3 meter? So what will be the volume of raindrop? So this will be 4 by 3 into pi into r cube. So this will be 4 by 3 into pi into r cube means what? 2 into 10 power minus 3 whole cube. So this is the volume of a raindrop. Now if I will talk about mass of the raindrop, so mass is equal to volume into density of the raindrop. So density is your what? First of all you write volume, that is equal to 4 by 3 into pi into 2 into 10 power minus 3 whole cube into what is the density? Density is 1000. Okay, so by using this you will able to find a mass. So what will be the mass? So from here what you will get? You will get mass of the raindrop. So mass of the raindrop is how much? Mass of raindrop. So mass of the raindrop you will get how much? If you will calculate, you will get 3.35 into 10 power minus 5 kg. Okay, now since raindrop is falling, so see here, raindrop is falling downward, force due to gravity is acting downward, okay, and displacement is also downward. So work done will be equal to force due to gravity into displacement. So since force due to gravity is your mass of the raindrop into gravity into displacement is your what? 250. For each part, I am talking about for each part. See here what they are asking, that work done by the gravitational force on the door in first and second half of the journey. So this first half, either you will take for first half journey or second half journey, you will get same answer. Why? Because both have same distance displacement traveled. Okay, So for first and second half of the journey, half of journey journey work done by gravitational force, work done by gravitational force on raindrop, on raindrop, right? So if you will put this value 3.35 into 10 power minus 5 into gravity has a value 9.8 into 250, so what you will get? You will get work done. So finally you will get work done is equal to 0.8 um, 0.082 joule for each half. So I hope you have understood this section. Now I will try to solve next section. Next section they are telling that next section now next section what they are asking, in next section they are asking that what is the work done by the resistive force in the entire journey if its speed on reaching the ground is how much? 10 meter per second. Okay, sorry. So see here, for example, a raindrop is coming down, okay, and it falls with the, at this point it falls with the 10 meter per second. It means that energy at this part, if I will take, this is your initial and this is your second is your final. So initial energy E1 is how much and initial energy E2 is how much? If I will found this two energy, then we will definitely able to find resistive force. Why I am telling you, see here, for example, energy at this point, total energy is your 100 joule, but at this point you will get 20 joule. So definitely where does this 80 joule went up? So by a resistive force. So we will use this method to find the resistive force. So can we write here resistive force is equal to total final energy minus total initial energy. So we have to use total final energy minus initial energy. So first of all, how you will find total final energy or total final energy or total initial energy? Let us talk about total initial energy. Total initial energy of the raindrop is equal to mg into h. mg into h. So h is what? Total height. Total height is how much? Total height is your 500 meter. So can we write here mass of the raindrop? So what is the mass of the raindrop? Mass of the raindrop is your 3.35 into 10 power minus 5. So 3.35 into 10 power minus 5 into what is the value of g? 9.8, and what is the total height? This is your 500. So you will get total initial energy. So if you will calculate this total initial energy, so you will get 0.164 joule. Okay, now let us talk about total final energy. So as rain drops here, before the strikes, it has velocity. It means that no potential energy is zero, but it has kinetic energy. So kinetic energy will be total energy, because total energy is equal to potential energy plus kinetic energy, right? So since here potential energy is zero, so definitely we are getting only kinetic energy as a total energy. So total final energy, how you will find? Total final energy will be equal to total final energy will be equal to now what is total final energy? So can we write total final energy as a kinetic energy, because there is no potential energy, because potential energy at the ground level is zero. That's why we can write here total energy as a kinetic energy, and this is equal to half m into v square. So what is mass of the raindrop? So we can write here mass of the raindrop as how much? Mass of the raindrop is how much? 3.35 into 10 power minus 5 into what is the velocity, that is equal to 10 square. Okay, so by solving this we will get 1.675 into 10 power minus 3 joule. Okay, so we have got total final energy total, and we have got total initial energy. So work done by the resistive force, work done by resistive force, work done by resistive force is equal to total final energy minus total initial energy. Since we have got total final energy as 1.675 into 10 power minus 3 minus 0. Total initial energy is your minus 0.164 minus 0.164. So this amount of resistive force is there. So it will be how much? It will be minus 0.162 joule. So negative sign indicates that resistive force is your resistive force is opposing in nature. Okay, so an object was coming down and resistive force is working upward direction, so angle between them is 180 degree, so definitely work done will be negative. I hope you all have understood now this. Thank you everyone.